This is our last lesson for chapter 2, 2.7, nonlinear inequalities. We're going to solve some polynomial inequalities, which means we're going to have to do some factoring and some rational inequalities. Students right now are working on the warm-up. Let's see if you remember how to solve just a plain old linear inequality. Ooh, this might be new for us now that we know what interval notation is. So you can write your solution using interval notation. Oh, yes, you do. Okay, I'm going to give them about 1 more minute. Except it's less than 2.
Oh yeah, might be right.
So
That's good. Good job.
by
Can you try to
two, you have to
write
multiply the
interval
x by
notation?
2 as well.
Yeah, probably.
How would you write all the values less than or equal to -2?
So that it will simplify the x. You just do it. Your way works, I just don't mind fractions.
Like that?
No.
Sorry, what'd you give your answer?
X is less than or equal to 2.
Nice. That's a
Yeah,
good
I like
answer.
I'm
That's a
proud of
good
myself.
answer.
Okay, a couple different ways you could do this. You could combine your variables with fractions. Personally, I moved over this first. I did this, and then I was like, "Oh, let's get rid of that fraction. Let's times both sides by 2." And you could have done that right away, also.
You did it right. You
Yeah, I just forgot to do it.
just forgot to do it right.
So we get -3x, and we get 2x minus 10 on the other side. All right, now moved over the 2x, and
Divided by negative x.
yes, divided by negative, gotta flip the sign.
Yeah.
Or you could have like tried to keep everything positive too. All right, should have gotten this.
Oh, that's right. That's what it meant.
Interval notation. Everything less than or equal to 2 would be everything from negative infinity up to 2, including 2. That's interval notation. That's how you're gonna write your answers today.
Oh.
Crowd goes wild. Okay, so we're just gonna step it up a notch with polynomial equations. Now here's the bad news. It's not as easy as solving linear ones, because linear inequalities are almost exactly like solving linear equations. You just have to worry about that silly rule if you divide or multiply a negative to flip the symbol, okay? That doesn't really work for anything larger than degree 1 polynomials with inequalities, okay? So instead, what we have to do is find the key numbers, and what that means is we're just going to solve the equation as if it was an equal sign. So you're going to start by finding all the real zeros. You know that's when your function equals 0. So we'll set our equation, we're going to make it an equation equal to 0. We'll solve it, usually by factoring, and find the key numbers, which are our solutions, or our x values, or our zeros, okay? So what we're going to have to do are something called test intervals. So we're basically going to draw like a little number line. Oh, you done this before?
These are awful. Yeah.
Oh, these are fun.
You think everything's fun.
Yeah, I was like, I said that for every single unit this year.
Key numbers go here. And then you have to like test the intervals.
We still have 3 more quarters of this stuff.
No, it's gonna change sooner or later. We only do this once.
Okay.
Wow.
Yeah, I sucked at this.
That's alright. Tyson.
Okay, so then you'll basically just like test them in the original inequality and figure out like which interval works, which doesn't, and then we'll write our answer using interval notation. So if it's things like between our key numbers, you know, from 3 to 5, from negative infinity to -7, whatever it is, we'll write it using interval notation. Okay. We'll do 1 quadratic, and then we'll do 1 degree 3 for the polynomial ones. Okay. So the first thing you do is you solve what I like to call like the related equation. You basically treat this as if this was an equal sign. And you find all the zeros, okay? Or you just think of this as an equation that we're solving. So I move the x squared over here, set this equal to 0 and factor. Ooh, look at this factoring one coming up again. That'd be negative 3 and positive 2. So we get 3 and we get negative 2, and those are our key numbers. Okay. So we draw our number lines. So I have key numbers of negative 2 and 3. And I'm just going to test numbers at each like interval of this horizontal number line. Now you can test any number smaller than negative 2 that you want to, or any number, like you think of a horizontal number line, like to the left of negative 2. You could do negative 10 if you wanted to. I usually keep it pretty small because I like to work with smaller numbers. I tested negative 3. All right, now you plug it into the original inequality. All right, I'm going to write out my work, but from here on out, you just have to plug it in. Careful though, there. I put a lot of negatives in this one. I end up getting negative 3 is less than negative 3 squared is 9 times 1, negative 9.
What's the 9?
Is that true?
No.
No. So that is not true. We can say that's false. We're going to put like a little F there.
Are you putting like on the number line, like right above it, or
Put up here.
That's
yeah, maybe
true.
like false, true, false.
Oh, yep, you can do that.
Yeah,
Wait,
isn't it always
Like this?
Yeah.
Okay, yeah, we can do that. My favorite number inside here is 0. You could do 1 if you wanted to. I think 0 is easier. All right, we get negative 6 is less than 0. Is that true?
Sure.
Yes.
Last time I checked.
True? All right, last one I'm going to test. I picked 4. Again, you could pick 10 if you wanted to, whatever you want. We do get negative 10 is less than negative 16. True or false, class? False. Okay, now, on your homework it says graph this on a solution set. So all you need to do to finish graphing this would be shade where it's true. Look at your symbol. Am I going to have open circles or closed circles? Open, yep.
So you don't need interval notation?
Oh, we're not done. It'll say graph your solution set, and then when you write your solution, you're going to write it using interval notation. So this would be open circle, negative 2 to negative 3.
Positive.
Oh, positive 3. Why did I get negative 3? I don't know. Why doesn't my eraser work?
Well, you work sometimes.
Back to my grouping.
Okay.
1.
Negative 2. Oh, my red pen doesn't work.
You broke it? Maybe
Yeah, I
twice.
dropped it like 18 times.
You want the red one?
Uh-oh.
All right. Degree 3. No problem. Solve the related equation. Okay. I would solve this by setting this equal to 0. I heard somebody say factor by grouping. You betcha. We got 4 terms here, so I can factor this by grouping. Can factor out an x squared to leave me with x plus 5. And this does work. I can factor out a negative 3. So this factors into x plus 5 and x squared minus 3. Okay, this one, if you have to set equal to 0 to solve this, you can. You get plus or minus the square root of 3. And then obviously negative 5 from that x plus 5. So I have 3 key numbers here. All right. To save time, I tested these for you. So you got -5, negative square root of 3, and square root of 3. Okay, so for this one I tested -6 and I got this statement. True or false? False. Okay, for this one, I tested -3 would be in between those. I got this statement. True or false?
True.
This one, you know I did 0.
False.
I got this. 0 is not greater or equal to 15. That is false.
Is it always going to be opposites?
No.
So you got false by that first T.
I don't know. That's a good question. Let me know after you do some homework. This one I did. What did I do? 2.
We need a nice Descartes phase rules.
I agree.
All right.
Descartes rules of T's or F's.
True.
Yeah, that would be a good one.
Now, since my symbol is equal to, I'm going to have closed circles at these key numbers. So it's going to be shading in between -5 and -√3. Closed circle here, shading on everything greater than -3 as well. So my interval notation would be closed bracket, -5 to negative square root of 3, closed bracket with the union, √3, infinity, parenthesis, always around infinity. Yes, write your answer using set notation. Or, sorry, interval notation, not set notation. Okay, I'm curious if you've done rational ones before.
Probably not. I don't know.
Okay,
We're probably happy.
that's the next half of this lesson. Is rational inequalities, rational meaning fraction, like so.
Maybe.
Okay, so the only thing that's different with these is we can have key numbers at its zeros, so we'll solve the equation again, and also at anytime it's undefined. All right, so you got to pay attention to what your denominator is. So we know it's undefined values is when the denominator equals 0, right? Or you can think about it like where you have your vertical asymptotes, because those values are undefined. So these two types of numbers make up our key numbers. So we'll solve this. You'll see we get a solution. We're going to get 8. Okay, that's one key number. What would my other key number in this example be?
5.
5, because it's undefined at 5. So you have to factor in both the 0 or the solution and also when the denominator is 0 for rational ones. Does this feel familiar? Okay. So whether you choose to do that right away, personally, I like to do it right away because I usually forget at the end. I see a rational one, I'm like, hey, when this is 0, I know I have a key number. So I have a key number at 5 right away. And then, just like before, I solve the related equation. So set this equal to 3. You could cross multiply. You can multiply both sides by x minus 5. Or you could cross multiply, whatever you want to do. Okay, let's solve this quickly. And we get 8. If you want to circle your key numbers, you can too. Sometimes that helps students. Key numbers. Another thing I kind of like to do with this key number is I put like a slash through here to remind myself like x can't be 5, right? X can't be 5. That'll help us when we go to write the interval notation too. All right, same thing as before. We're going to do our test intervals. So we got 5 and 8. Okay. Don't worry, I did this for you. when I plugged in 4. Again, original inequality, and you'll obviously get practice with this on your homework, so not too worried about plugging the numbers in. Use your graphing calculator to save yourself time. Okay, I know mental math is good, but we're in pre-calculus now, so use your calculator if you need to, just to save time.
I'm surprised you didn't use 0.
Oh my gosh, you're right. Oh, that's not like me. I'm sorry,
Bring
Steve.
it up.
Oh, what the heck? Okay, I got this when I plugged in 4.
True.
Yeah, true.
True. Yeah, if I would have plugged in 0, that would have been easy. -7/5. Okay, that still would have been true. True. Oh, that's funny. Here, I plugged 6 in. Yep. Again, 6, 4, 7 doesn't matter. I got
Where
this.
it's always truthful. That's where it's always opposite.
I'm sure it is mostly fine. It's just.
I feel like I should know that pattern or why it works, but I don't.
I feel like sometimes you just check just to make sure.
Yeah.
I feel like there's probably like in math in general, there's always like those weird situations where it doesn't work.
Yeah, it's like.
Okay, there I got 11/4, which that's like 2.75. Less than or equal to 3. When I plugged in 9, that's true. Okay, now here's a tricky thing. So my symbol is equal to, remember, you can't be equal to 5, so there is an open circle here,
Oh, yeah, that's right.
because that's where my function is undefined. Still a key number, open circle, closed circle here, because that was my solution. So it'd be -infinity to -5, open circle, union, close bracket, 8 to infinity. Yeah, not too bad, right? I told you this was fun.
Oh, fun. Okay.
Yeah, we're gonna do one that's a little bit harder.
Alright, you crossed the line a
This
little
is
bit
where
here.
the fun kind of.
Hey, I'm doing all the testing for you. Calm down.
Actually.
Yeah, you can do the course on assignment too and just give us all 100.
I've had my practice days.
Me too.
Okay, so right away, I see rational fraction. So I look at my denominator. I see when is this 0? Or again, I like to say what connects not b is another way to think of this. So I already have 2 key numbers at 1 and -1. Okay, and again, maybe put the slashes through to help remind yourself. X cannot be these. Solve the related equation. All right, now these you definitely do. These are like classic algebra 2 problems, how to solve these. So there's a couple ways you could do this. You could make common denominators and add these together. I wouldn't recommend doing that. What you've probably been taught to do is to multiply both sides by the LCD and get rid of all the fractions. So your LCD here, your LCD, your least common denominator, well, here you have a denominator that has a factor of x minus 1. Here you have a denominator with a factor of x plus 1. Here you have a denominator with just a factor of 1. So your LCD is x minus 1, x plus 1. Yeah, so what we're going to do is we're going to multiply both sides. I'm going to write it out here. Multiply this side by my LCD. And what this does is it clears all your fractions. Okay. This is straight algebra. So here what happens when I take this and distribute it to here, the x minus 1s would cancel, and we'd be left with 3 times x plus 1. Okay. Now, when I distribute that to that second term, The x plus 1s would cancel. So I'm left with 2x times x minus 1. Okay, remember doing this?
Yeah.
Over here, I have negative 1 times all that. Nothing cancels. Okay. So let's go ahead and clean this up. 3x plus 3 plus 2x squared minus 2x equals negative. I'm going to multiply these together first. That's just x squared minus 1. And with that negative out there, or times that by a negative 1, it's going to become negative x squared plus 1. Set this equal to 0. Combining all your like terms, you get this. This which doesn't factor.
Quadratic.
So you'd have to use a quadratic formula. And you end up getting the square root of negative 23. So those are imaginary, so we can kind of stop there. Our only key numbers then are 1 and negative 1. Oh, all that work for nothing.
Wow.
Love you guys. Okay. All right. I'll quick do the test for you. So I did. Let's stick with my color coordination here. Why do you think that one broke? I did negative 2. Are you guys okay with me doing this, or you want to practice it?
You
got homework to practice.
I got that,
Yeah, it's true.
which is true. Yep, 0 would be false. You end up getting negative 3 is greater than negative 1. Sorry for getting in your way. And then I did 2. Ended up getting 3 plus 4/3. I didn't even go any further when I plugged it back in. 3 plus 4/3. I was already like, I didn't even want to deal with fractions. I'm like, hey, I know that's greater than negative 1.
Sometimes you just gotta be sure.
Okay. So shading over here. Open or close circles with these ones. Open, because these are my undefined values. Good. So everything from negative infinity to negative 1. Parentheses. Everything from 1 to positive infinity.
We're so smart.
Yeah.
Okay.
Oh, that's what we're alive.
That is solving inequalities with polynomials and with rationals. The only last thing we're going to take a look at, these problems are kind of like a good appliance of one we would maybe need to like solve inequalities if we were asked to find the domain of something like this. Okay, so what do we know about the domain, I'm looking at number 1, of radicals, of square roots?
It has to be greater than 0.
Greater than or equal to 0. Yep, exactly. We know that whatever underneath here has to be greater than or equal to 0. So really, this is just solving now an inequality. Okay, this one's just a straight up polynomial. Don't have to worry about undefined values or anything like that. You just solve the related equation. You get plus or minus 2. All right, to save time, I'm telling you right now, when you do this, you get false, true, false. Now we can include these because it can be equal to 0. So my domain would be -2 to 2.
This one looks fun.
Yeah. Super fun. We'll end with this one. What are we here till 57? Oh, we got time to do this one. Use a graphing calculator to verify your results. We will do that once we finish this one too. Okay. So again, same thing. Whatever's underneath, I like to call that kind of like my argument. Whatever's underneath my radical, that has to be greater than or equal to 0. Okay. So, right away, if I factor my denominator, I see some undefined values, some key numbers. X cannot be 7, and X cannot be -5. Now when I go to solve this related equation, times both sides by the denominator, I get X to 0. There's another key number. 3 key numbers here. That's a solution. Those are undefined values. All right, here is the results. -5, 0, and 7. I got false, true, false, true. Should that a little bit longer. Should I write a 7?
Yeah.
I can't wait till we find one that doesn't have this.
Yeah.
Right? Okay, now, obviously testing points. Here's where you gotta be careful of. So inside here is true. Open or close circle with -5.
Open.
Open. What about 0?
Closed.
Closed. It's a solution. Good. It's a solution. Everything to the right is 7. Open circle is 7. Okay, does this make sense, everybody?
Yep.
I'm not doing anyone a disservice by skipping steps.
No.
Okay, so my domain then would be -5 to 0, close bracket on 0, union, open parentheses, 7 to infinity.
Oh, did it wrong.
I did it wrong?
No.
No.
Oh! Awkward, never wrong.
Yeah. Never wrong.
I learned that today earlier.
Okay, so I'll quick pull up our grapher. Okay,
Oh my gosh, you're right.
so let's look
I
at
can't believe.
the first one. Square root of 4 minus x squared. Zero idea what my window's set at. Does my domain look like it's from -2 to 2?
Yes.
Yes, that's what we found.
Looks beautiful.
It's cute.
Oh my gosh, you were right there too.
No.
Okay, next one. Square root. Can never have too much practice typing in rational functions into your calculator because you'll do this a lot like in calculus too, and I can't tell you how many times students are like, oh, I'm doing wrong, I'm getting these numbers, yada yada, and all I gotta do is look at their y1. I'm like, you didn't put parentheses around your denominator. Okay.
Is that right?
Here's a piece -5 to 0. Here you can see 7. Obviously, I cut off here at 10, but 7 to infinity. Super cool.
So fascinating.
Yeah.
Math is fantastic.
No.
Okay, that was 2.7. Thanks for watching.
You are very welcome.
Thanks for watching.
Yeah,